Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and we will be presenting about wheat mill unit operation. These are our group members. So, the principle of operating for wheat milling system encompasses a series of processing designed to transform raw wheat into flour. These processes include cleaning, grinding, and separating, which are essential for producing high quality flour. First, let's talk about wheat cleaning. This is a process that removes impurities from wheat to ensure that the final flour is clean and safe. It is done in two stages, primary and secondary cleaning. In the primary cleaning stage, we use machines such as aspirators, magnetic separators, vibrating separators. In the secondary cleaning, we use machines such as distoners, sorcerers, and gravity separators. Cleaning is essential for improving flour quality, preventing damage to machines, and ensuring hygiene standard. Next is wheat conditioning, which prepares wheat for milling by adjusting its moisture content. This involves adding water to the wheat and letting it rest in a process called tempering. This allows moisture to spread evenly through the wheat kernel. The main goal of conditioning are to toughen the bran to prevent it from breaking into small particles, separate the germ more easily to help extend the flour shelf life, soften the endosperm to reduce energy during grinding, maintain the right hardness for starch control, improving sieving for balanced milling, and ensure proper moisture for better baking. The ideal moisture content for milling is between 15% and 17% depending on the wheat type. Conditioning is done using two types of equipment, which is low-speed mixers or high-speed dampers. Low-speed mixers adds water slowly, while high-speed dampers mixes faster and reduce tempering time. Modern equipments like debranding machines removes outer bran layers, reducing ash content and improve flour extraction. Wheat is then stored in a tempering bin to rest before milling. Lastly, tempering times varies. Low-speed mixers takes up to 72 hours, while high-speed dampers reduce this to 7 to 12 hours. Both wheat cleaning and conditioning are essential for producing high-quality flour with optimal efficiency.
For the unit operational of key stages of the milling process in wheat processing is including breakage, purifying, and also the reduction that are critical in transforming wheat grains into high-quality products such as flour. The first stages is breakage, which is the initial step in the milling process. The objective here is to achieve a preliminary separation between the bran and also the endosperm of the wheat grain. This is done using brick rollers, which are grooved rollers designed to crush the wheat grain. Next, we move to purifying, and the essential step for improving the quality of the endosperm. The goal here is to separate the fine endosperm particles, which is semolina, from the bran and impurities. This is achieved using plant sifters cascaded to each breakage roller mill. Plant sifters are equipped with vibrating sievers to sort particles based on size. By the end of this stage, we have a cleaner and more refined grade of endosperm and bran products. The final stage is reduction, where the endosperm is milled into flour. This process involves smooth surface rollers that are gently grind the semolina particles. The objective is to achieve the desired flour texture by reducing the size of the endosperm particles further. Multiple reduction steps ensure that the flour meets the required specification for fineness and consistency. To summarize, the wheat milling process consists of breakage, which is separating bran and endosperm, purifying, that refining semolina and removing bran, and also reduction, that grind the endosperm into fine flour. These processes work together to produce high-quality flour to various applications. That's all from me. Let's move to the next presenter.
Okay, so now I'll be discussing on the equipment setup and design. So the first equipment is roller mill. So let's first take a look at the equipment setup. So in a wheat roller mill, cylindrical rollers are often in the form of truncated cones or toruses that apply mechanical forces to the wheat kernels, which are ground against a stationary or bowl-shaped surface. The rollers are powered by motors rotating around a fixed axis to efficiently process the wheat. The feed system ensures a consistent flow of wheat into the mill through gravity, springs, or hydraulic clamps, ensuring even distribution across the rollers. Once the wheat is ground, the mill material exits through an output system ready for classification or collection. This efficient design ensures high-quality flour production while maximizing throughput. Now let's take a look at the design. So in wheat roller mill, the rollers are designed with a width to diameter ratio between 0.27 and 0.32, with diameters ranging from 200 mm to 2500 mm to suit various milling needs. So load distribution is carefully calculated considering factors like mass, velocity, and gravitational force, with gyroscopic effects impacting pressure on the wheat. The rollers rotate around a fixed point with their angular velocities and moments of inertia, optimized for milling efficiency. The design minimizes stress and damage to the wheat kernels, ensuring a high-quality product. Suspension systems maintain proper alignment and friction is minimized, especially in larger mills, to improve milling performance. Okay, so secondly, let's take a look at the equipment setup and design of electrical stone mill. So as for the equipment setup, two circular stones grind wheat into fine flour. The upper stone rotates while the lower one remains stationary, powered by advanced mechanism for consistent operation. Composite stones mounted on durable metal plates ensure enhanced efficiency and longevity. The friction-based grinding system carefully preserves wheat components like starch, protein, and unsaturated fatty acids by minimizing heat generation. This process combines the precision of modern technology with the essence of traditional milling, delivering high-quality flour with optimal nutrient retention. As for the design, the wheat electrical stone milling process utilizes compression, shear, and abrasion to grind wheat kernels, achieving a theoretical 100% extraction rate by retaining all kernel components in the flour. It produces a uniform particle size distribution, including finer particles below 85 microns, enhancing both the technological and nutritional quality of the flour. Blending traditional aesthetics with modern ethnicity, this method caters to consumers seeking natural, wholesome products while maintaining superior milling performance.
Planticiphers are crucial in wet flour production and which influence both extraction yield and product quality over time. Planticiphers have undergone significant change like increasing number of compartments, enlarged sifting surface, sifting frames, fabrics, cleaning system, and enhanced accreditation suspension system. This machine usually used after grinding process. For material inlet and discharge, milk wheel is put into the machine by controlled distribution system, which helps to separate the product. Next, suspension system are using the flexible rods or composite materials. For example, in modern manufacture, they usually use plastic infused with glass fibers as their rods. It is allowed to control the oscillatory motion for efficient shifting. Next, accreditation system setup. The machine are powered by an unbalanced mass that must to make oscillatory motion. Lastly, multiple stack shifting frames are used in this machine with various mesh size to ensure good separation between the milk well into different sizes, which allow precise clarification. Next, plant sifter, plant sifter equipment design. Frame construction made for this machine, the frame construction made from steels or aluminium, which is a strong materials. Next, the shifting area range for this machine from 30 meters square to over 90 meters square, which is depends on the model and the output need. Next, the shivers are made from the durable synthetic materials that can separate the milk materials by sizes. Next, the suspension system design have three design, which include suspended, free, oscillating, and pendular system for good performance movement. Other than that, the accretion system designed from unbalanced mass, which allows for 2 degrees of freedom, which is in circular or elliptical motion. For modern plant sifter, the machine can process up to 25 tons per hour and speed and motion in range from 180 to 300 RPM, but it is adjustable. This machine also have automatic cleaning with easy access for maintenance. Next, magnetic separators should be installed after the initial cleaning stage, but before the milling process. This ensures that any metals contaminants are removed before the wheat is ground into the flour. Meanwhile, for the large-scale operation, magnetic separators should be set up in multiple stages of the processing line, which provide multiple ways to capture contaminants. First, the magnetic drum separator is one of the most common types used in the wheat mills. It is typically positioned at the inlet of grain handling system or just after the initial cleaning operation. It is to attract the metal particles while allowing the clean wheel to pass through. Next, for the overband or cross-belt magnets, it is installed above conveyor belts transporting wheel. As the width moves on the conveyor, the magnet attracts metal contaminants. Next, the plate magnet. The plate magnet is typically placed inside the gravity-fed clutch hoppers or pipelines where the weight flows. These magnets are installed horizontally or vertically to attract metal particles. Next, the drawer magnets are usually in the gravity-fed system, commonly found at the bottom of the hoppers or bins where weight is stored temporarily before milling. And lastly, we have electromagnetic separators, which is an ideal for situation requiring for a stronger magnetic field to remove very fine metal contaminants. These separators are often installed where high-intensity magnetic fields are needed to deal with stubborn metal particles. Next, magnetic separators are designed to handle the specific flow rates of the milling process without causing bottlenecks. Their dimensions are tailored to fit spots, conveyors, or channels, ensuring smooth operation. Next, magnetic field strength is a key factor. The separators are designed to capture everything from large metal pieces to the fine iron dust. This is measured in Gauss, with value between 8,000 and 12,000 Gauss being ideal for wet milling. Next, the magnets are typically rare earth magnets like neodymium, which provide high magnetic strength and long-lasting durability. The housing is made from standard steels, ensuring corrosion resistance and compliance with food grade standard. Lastly, ease of maintenance are vital. A modular design allows for quick access and replacement for magnets. Smooth surface prevent product build-up, making cleaning and upkeep much simpler while maintaining hygiene.
Good day everyone, I'm Fazana Shaira. We'll be presenting the efficiency of a wheat mill focusing specifically on wheat characteristics and operational factors. First, let's discuss wheat characteristics. The moisture content of wheat is an important factor. Ideally, wheat should have a moisture level of about 12%. If the moisture is too low, the wheat becomes brittle, leading to excessive breakage during milling. When the moisture is too high, it makes the wheat sticky, causing it to clog the rollers and slow down the process. The conditioning process, where water is added before milling, helps achieve the right moisture balance. Another important characteristic is kernel hardness. Hard wheat requires more energy to grind, whereas soft wheat is easier to mill. Adjusting the milling parameters to match the hardness of the wheat is important to maintain efficiency. Now let's move on to operational factors. First is the feed rate. Overloading the mill can lead to uneven grinding, increased wear on the equipment, and a drop in flour quality. Underfeeding, however, results in underutilized capacity and wasted energy. Automating the feeding process can help maintain a consistent flow and optimize productivity. Energy management is another important operational factor. Milling efficiency relies on a consistent and reliable power supply. Interruptions or fluctuation in energy can halt operations and damage sensitive equipment. Using energy efficient motors and monitoring power usage not only reduce costs but also ensures smooth and uninterrupted operations.
Next, I will explain about the environmental factors and the milling equipments that would affect the process of the unit operation. For the environmental conditions such as the temperature, where if we use high temperature during the operation, it can cause overheating towards the equipment, which will reduce the quality of the product and the grain, thus reducing the overall process efficiency. Other than that is the humidity. If the environment is too humid or moist during the milling process, it can reduce the operation efficiency, which will also affect the product's quality. For the conditions of the milling equipment, such as the feed roll, where if we use worn out rollers, it can reduce the efficiency and the quality of the wheat product, which will decrease the process efficiency. To improve the operations efficiency, we can use less intensive energy equipments, can save energy while maintaining the productivity of the process. That's all from my group. Thank you.
Hello everyone, my name is Nur Shahada binti Shahar Effendi and my matrix number are A192719. Today I will be presenting an example of food product made using wheat milling, which is bread. The wheat milling process is a critical step in transforming harvest wheat grain into fine flour. When wheat arrives at the mill, it undergoes a cleaning process. This step removes impurities like stone, dust, and plant debris using mechanical sifters, magnet, and separators. Clean wheat ensures the quality of the flour and final product. The clean wheat is then conditioned. This involves adding controlled amount of water to the grain and allowing them to rest. Condition soften the outer brown layer and tough with the inner endosperm, making it easier to separate during milling. After conditioning, the wheat kernel are passed through a series of rollers. This roller crush the wheat, breaking it into a smaller pieces. The process is repeated through a different roller mill, gradually reducing the wheat to the fine flour while separating the bran and the germ. The ground materials is sent through a sifter which separate the flour from the coarser particle like bran and middling. This step ensures that only the finest, softer flour is collected. The final flour is often blended to meet specific quality standard. The dough undergoes fermentation where yeast ferment sugar produce the carbon dioxide. This process causes the dough to rise, creating the light, airy texture characteristic of bread. After fermentation, the dough is shaped into loaf and allowed to proof. Proofing is a secondary fermentation that further develops flavor and texture. The proof dough is baked at high temperature, solidifying its structure and giving the crust its golden brown color. The mild reaction during baking contributes to bread flavor and aroma. Once baked, loaves are cooled to room temperature to prevent condensation in packaging. After cooling, they are sliced and packaged, ready for distribution. That's all for me. Thank you.
So, hi, Assalamualaikum. My name is Habib Rahman bin Ahmad Saifullah. My matric number A187856. So, I will continue. The last part is another example of wheat meal product. So, I take a biscuit from the Hapseng cream cracker. And the production of Hapseng cream cracker start with wheat cleaning, where wheat grain are carefully cleaned to remove impurities like dirt and stone to ensure that only high quality grain are used. Next, in the milling and grinding stage, the clean wheat is conditioned with moisture, which helps separate the bran, germ, and endosperm. The conditioned wheat is ground into fine flour using a roller mill, providing the perfect consistency needed to the cracker. Finally, the milled wheat flour is mixed with ingredient like a vegetable oil and a leavening agent to create a dough. So this dough is shaped and then roll out and also next baked into the perfection to produce the delicious Hapseng cream cracker. And From the cleaning to the ingredient mixings, this meticulous process ensure that cracker maintain their consistent texture, taste and quality.